Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfazli binti Ahmad Darus, and today we are from Group 3. I'm going to present to you the Industrialized Building System mini project. So now I'm going to start with project brief. So the project brief, our project is to redesign a conventional two-story building into a modular structure using the Industrialized Building System approach. The redesign complied with JKR IBS catalogue and Malaysian standard practice. The prefabricated structural elements such as beams, columns, slabs, floors and staircases were coordinated using modular principles. IBS layout drawings were prepared to illustrate structural arrangement and local distribution of the redesigned building. Structural or 3D modeling software was used to visualize the IBS design and support understanding of a real construction implementation. Second is the objective. The first one is to redesign a conventional two-story building structure using industrialized building system components. Second, to develop structural detailing that complies with Malaysian standard practices. Third, to evaluate and achieve an acceptable IBS score for the redesigned building in the compliance with the IBS score conclusion method recommended by the relevant Malaysian authorities.
Okay, Assalamualaikum. My name is Muhammad Naim bin Rosli. So I will present about project scope. So our project scope is IBS based redesign of an existing two-story building using modular coordination by follow JKR IBS catalog 2017 through 2020. Secondly, BIM modeling and IBS score evaluation for design, visualization and IBS adoption level. Lastly, preparation of standardized IBS layout drawing. So I will present about modular drawing structure. Okay, for column we are using same size like 400 multiple by 600 mm from ground floor to top floor. Okay, for ground floor plan, beam size mainly using 300 multiple by 500 mm and 300 multiple by 600 mm to design this ground floor beam, and it support ground floor and improve loads. Okay, ground floor plan consists of shop area, bathroom, staircase and service space. Okay, for first floor is residential layout that consists living area, bedroom, kitchen and bathroom. Beam size for first floor, standardized beam size for repetition like ground floor. Okay, for top floor beam size mainly using 300 multiple by 500 mm and 300 multiple by 800 mm. Okay, for top floor arrange using the same modular grid to ensure structural consistency from lower floor.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Haikal bin Hasmizan, metric number 221201921. Okay, I will present about the 3D drawing, okay, using Revit software. Okay, now we go through into the drawing. Okay, first, this is a structure plan. Okay, so now we start with a front view, okay, which is we can see, okay, the details of the building, which is we start with base, and then for level 1 height is 4000 millimeter, which is 4 meter, and then for level 1 for height from level 1 into the roof also 4 meter. So the total height of this building is 8 meter. Okay, this is a front view. Okay, and then we go through into the side view. Okay, we can see the partition of the partition for the each area in the building. Okay, this is a back view. Okay, so this is a structure drawing. Okay, structure drawing before we go through into the architecture drawing, okay, to make the building is more real. Okay, so from here we can see, okay, we can got the idea, the details, okay, where the stairs, okay, where the location of column, beam, and from here, okay, we can see we can apply and we can propose, okay, the material that we use, okay, for this construction. Okay, now we jump into the architecture plan. Okay, this is a front view of the architecture plan for this building. Okay, this is side view. okay, we can see okay the location of the windows, okay, the location. So all the details of this project, okay, will we show okay at this architecture plan. Okay, this is a back view. Okay, we can see okay what is the location of roof, okay, the shape of roof, okay, the type of roof. Okay, we can see okay at the back and the front, this building have a shutter roller. Okay, this is the base level for this project, level 1, and this is a roof plan. Okay, and this is a detailing of this project. Okay, we can see have the stairs, okay, that are connected from a basement into the level 1 level 1. Okay, we can see the partition of the room. Okay, we can see the partition of the each buildings. Okay, so this is this project lah.
And I will be presenting on the IBS score assessment for our redesigned two-story building. My presentation will focus on the IBS score concept, element selection, and the structural and architectural components used in this assessment. The slide explains what the IBS score is. The IBS score is a standardized assessment tool used to evaluate the level of industrialized building system adoption in a building project. The calculation of the IBS score follows the CIDB IBS score manual CS 18-2018. The maximum score is 100 points, and it is based on 3 main categories: structural system, wall system, and other simplified construction solutions. The slide explains how the scoring works and why it is important. The IBS score considers factors such as use of prefabrication, standardized components in accordance to MS 1064, modular coordination, VM usage, repetition in layout design. A higher IBS score indicates better construction efficiency, improves constructability, higher quality control, and reduced reliance on site labor. For this project, the IBS score is calculated to evaluate the effectiveness of IBS implementation in the redesigned two-story building. The assessment focuses on superstructural elements only, and the result provides an objective measurement of IBS adoption. The slide explains how the IBS elements were selected. The elements were chosen based on the architectural and structural features of the redesigned two-story buildings. All selected elements follows the CIDB IBS score manual CS 18-2018 classifications and IBS vectors. The main components considered include structural systems such as beam, column, slab, and roof system, wall system for both internal and external walls, simplified construction solutions, including standardized component repetitive layouts, and productivity-enhancing technologies. The slide further explains the selection criteria. The elements were chosen based on the construction process implemented, the degree of prefabrication, compliance with MS 1064. These selected elements form the basis for the IBS score calculations. IBS factors and scores are aligned according to the system type used, the extent of coverage, the level of standardized achieved. This slide presents the first floor beam schedule. All beams listed are prefabricated beams, showing a high level of IBS adoption. The beams vary in length depending on grid location, but they maintain a consistent cross-section dimension of 300 by 600 millimeters. Thus, standardization improves manufacturing efficiency, reduces formwork variations, and supports modular construction principles. The slide shows the roof beam schedule. Similar to the first four beams, the roof beams are also designed as prefabricated elements. Using prefabricated roof beams improves installation speed, reduces on-site labor, and enhances construction quality control. The slide presents the ground floor column schedule. The columns are standardized in size and designed to support prefabrication and repetitive construction. Standardized column dimensions help reduce production costs and simplify site installation, contributing positively to the IBS score. This slide shows the first floor column schedule. The continuity in column design between floors ensures structural efficiency and ease of construction. Repetition of column types improves constructability and aligns with the IBS principles. This slide presents the first floor slab system. The slab design supports simplified constructions and allows better coordination with prefabricated beams and columns. Standardized slab construction improves site productivity and reduces construction errors. This slide shows the door schedule. The project uses standardized door sizes and manufacturer-based specifications, including roller shutter doors, flush doors with flick louvers. Standardization of door improves installation efficiency and supports IBS simplified construction solutions. This slide presents the window schedule. All windows use aluminum frames with standard configurations such as casement windows, top-hung windows, adjustable louver windows, fixed louver windows. Using standard window sizes and manufacturer specifications improves repetition, reduces custom works, and contributes to a higher IBS score.
My name is Siti Natsira binti Musi. Today I will explain how to calculate the IBS score for my project. The IBS score measures how much prefabricated is used in construction. It has 3 parts that added together to give a final score out of 100. Part 1 is the structural system. The formula is construction area divided by total area multiplied by the IBS factor then multiplied by 50. For the ground floor, I have prefabricated beam and in situ column with a construction area of 184.5 square meters. The total building area is 553.5 square meters. So the coverage is 184.5 divided by 553.5, which equals 0.33. The IBS factor for this type of system is 0.7. So the calculation is 0.33 times 0.7 times 50, which gives 11.6655 points. The first floor is the same with prefabricated beams, in situ column and prefabricated slab, also giving 11.655 points. For the roof, I use fully prefabricated metal trusses which have an IBS factor of 1. The calculation is 0.33 times 1 times 50, which gives 16.65 points. Adding this together, part 1 equals 39.96 points. Part 2 is the wall system. The formula is wall length divided by total wall length multiplied by the IBS factor then multiplied by 20. The total wall length in my building is 232.1 meter. For external wall, I use block work with a total length of 128.4 meter. The coverage is 128.4 divided by 232.1, which equals 0.553. The IBS factor for block work is 0.5. So the calculation is 0.553 times 0.5 times 20, which gives 5.53 points. For internal wall, I use prefabricated panel with a total length of 103.7 meter. The coverage is 103.7 divided by 232.1, which equals 0.447. The IBS factor for prefabricated panel is 1, so the calculation is 0.447 times 1 times 20, which gives 4.94 points. Adding this together, part 2 equals 14.47 points. Part 3 has 3 subcategories. First is standardized component. I check if beams, column, walls, slab, door and windows use standard size. For beam, 50 out of 66 are standard, which is 76% and give 4 points. All 44 columns are standard, give 4 points. All walls are 232.1 meters, use standard thickness, giving 4 points. All slabs at 30 square meters are standard, giving 4 points. Doors are not standard, so 0 points. Windows are all standard, giving 4 points. This total 20 points, but the maximum allowed is 60 points. The second is repetition of layout. The floor-to-floor height is 4000 millimeters for both levels, which means 100% repetition. This gives the full 6 points. Third is productivity enhanced solution. I use prefabricated and modular construction and prefabricated staircase. This gives 2 points out of possible 14. So part 3 equals 60 plus 2 plus 2, which is 24 points. The final IBS score is part 1 of 39.96 plus part 2 of 14.47 plus part 3 of 24 equals 78.43 out of 100. This shows that my project has a high level of industrialization with good use of prefabricated and standardized components. Thank you.
Last but not least, conclusion. The mini project successfully redesigned a traditional 2-story building using the industrialized building system in compliance with JKR IBS catalogue and Malaysian standard practice. The use of prefabricated beams, slabs, roof system and standardized components improve construction efficiency, quality and coordination of building elements. The use of prefabricated structures and reusable formwork system maintain the original functional layout while ensuring constructability and structural performance. The redesigned building achieved an IBS score of 78.43, indicating a high level of IBS adoption and confirming IBS as an effective approach for enhancing productivity and industrialization in Malaysia. Thank you.